All right, today we're learning the quadratic formula, how to solve any quadratic equation with the quadratic formula. So make sure that you know the formula. X equals, I'll do the Pop Goes the Weasel song. Make sure you know Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you don't know that song, Google it. I learned it using VeggieTales song with Jackie Payne in high school. The VeggieTales song is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So whatever you prefer. All right, so let's look at an example. Example 1, say you have x squared minus 4x equals 12. Well, keep in mind your equations have to be in ax squared plus bx plus c equals 0 format. It has to be in standard form. And make sure you do get the notes, the steps here on the side. We will get those down. But yeah, make sure your equation equals 0. Nothing should be on the right side. So this format is incorrect. Make sure you move this 12 to the other side. So x minus 4x, subtract 12. That way you can have 0 on the other side. From there, you're going to label your a, b, and c. The a value is 1, the number in front of the x squared term. The b value is your coefficient of your x term, which is negative 4 is the number in front of x. The negative stays with it, negative 4. And your c value is negative 12. So make sure you write that down. Even I, as a teacher, write that down. Don't skip that step. And then sing the song again. X equals negative b, put a parentheses where you see b, which is negative 4. Plus or minus the square root of b, parentheses again, negative 4. Squared minus 4a, 1, parentheses 1, c, negative 12, all over this whole sentence, 2a, parentheses 1. So you're writing in standard form, you're writing your formula as you plug in your numbers into your B, A, C, A. Then do your math, X equals, negative times negative is a positive, 4 plus or minus the square root, negative 4 squared. What does that mean? Negative 4 squared, you can make a note here on the side. Negative 4 squared means negative 4 times negative 4, which is a positive 16. Not plus, but multiply. Negative 4 squared is 16. This will always be positive. Whatever number is inside of here, whatever your b value is, when you square it, it always ends up with a positive product. Next, we look at these 3 numbers right here and multiply them and look at the signs. Between these 3 numbers, how many negatives do you see? You see 2 negatives right here, okay? So make sure you notate that if you have a negative times a negative, that gives you a positive. If you have a negative times a negative times a negative, that gives you a negative. Make sure you know that. So 2 negatives multiplied gives you a positive. 4 times 12. 4 times 12. It's 48, right? 8 and then 4. 48. Make sure you show your math if you need to. Negative, negative, positive. 48. 4 times 1 times 12 is 48. All right. From there, you do your little division bar. 2 times 1 is 2. X equals 4, right? You don't have to put positive 4 anymore, just 4, plus or minus 16 plus 48. Again, do your math, 16 plus 48, 14. Try not to use the calculator unless you have to. that should be a head problem, but I showed you, by hand. 48 plus 16 is 64, and divided by the 2, okay? Some people, I usually don't keep dividing by 2 until the very end to save room, which you'll see on the next problem. And then, once you have your radical 64, well, simplify. What is the square root of 64? It's 8. 8 times 8 is 64. Make sure you have your perfect squares listed somewhere close by. You should have them all listed. Right? Keep going all the way down to 200. Okay, so 4 plus or minus 8 divided by 2. Create two cases. So your first x-intercept, first solution to this equation, right? 4 plus 8 divided by 2. And then your second solution is 4 minus 8 divided by 2. 12 divided by 2 gives you 6, right? 6. So your first solution, x equals 6. 4 minus 8 is -4. Divided by 2 equals -2. Your second x-intercept is -2. If you were to graph this, your parabola would go through 6 and -2. Your parabola, that's where your function will cross the x-axis, where your function equals y at 0. Okay, so that's how you find your x-intercepts by hand, where you find the x value, right, of this equation, where it equals this 12 by hand. So if you were to plug it in, you can plug it back in. 6 squared is 36 minus 4 times 6, so 6 squared, so 36 minus 24, right, because 4 times 6 is 24. Is 36 minus 24 12? It is. That's how you know you did it correctly. Try the -2, plug it back in. -2 squared is 4, and then -4 times -2 is 8. So is 4 plus 8 12? It is. So you can always double check your work that way. That's example 1, okay? You have to create 2 solutions all the time because most parabolas, or not most, but many, have 2 solutions. Some have no solution, and some have 1 solution, but make sure you figure out, are there 2 solutions? Example number 2. All right, that was the VeggieTales song. Let's do Pop Goes the Weasel. Pick one to memorize, right? All right, next one. This is an irrational example. So say you have, write the formula again if you need to. Let's do Pop Goes the Weasel. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Make sure you know that. All right, example number 2. Say you're given a quadratic function, 2x squared plus 4x equals -2x más 6, right? So remember, you should have no terms on the right side. This got to go. This got to go, right? So undo subtracting 2x by adding 2x, right? We're going to add 2x under this x. These are the same like terms. We're going to subtract this 6, get rid of it, so subtract it over here, right? That's its own term. There's no other solo numbers on this side of the equal sign, right? So rewrite your equation in standard form. 4 plus 2, right? 4 plus this 2x gives you 6x. Then we subtracted the 6 equals 0. So now we're in standard form, okay? Make sure we go over the steps as well. Make sure you write the steps down somewhere in your paper. All right, A, B, C, D. Your A value is 2. Your B value is +6. Your C value is -6. Okay. Let's do Pop Goes the Weasel. Pop Goes the Weasel. Here we go. Me. X equals negative b, parentheses, 6 plus or minus the square root, make it long, of b, parentheses, b, which is 6, squared minus 4a, parentheses, 2 a c, negative 6, all over 2, parentheses, a, right? X equals negative 6b plus or minus the square root of b, which is 6, squared minus 4a, which is 2, c, negative 6, all over 2 times a. Okay, so let's just do our math. Negative 6 plus or minus 6 squared is 6 times 6, which is 36. Minus, all right, there's 2 minuses there. Between these 3 numbers, there's 2 minuses, so that's a plus when you multiply that. 4 times 2 times 6. 8 times 6 is 48. Okay, let's add those together. 48 plus 36. 48 plus 36, 14, 70, 84. Right? 14, 70. Double check your math. All right, let's go ahead and do this out. So radical 84, you cannot simplify that to one number. There's no number times itself that gives you 84, no whole number. 6 times 6 does not give you 84, 7 times 7 does not give you 84, 8 times 8 is 64, 9 times 9 is 81, 100 times, 10 times 10 is 100, so it's gonna be a decimal, 9 point something, but no decimals, all right? We don't want decimals. So instead, create your factor tree. What times what gives you 84? Just start thinking about numbers. Try a 2 or a 4, right? There's a 4 there. 4 works because 4 goes into 8 twice. 4 goes into 4 once. So 4 times 21 is 84. Just pick 2 numbers. Keep going. 7 times 3, and then 2 times 2. Make your tree. If you don't know how to do factoring, watch my video on that. No, factor tree or radicals. Look for radicals. Circle your twins, and then circle your non-twins. So your twins come out as 1, non-twins stay in. 7 times 3 is 21. Bring down your plus or minus. Bring down your negative 6. Bring down your divisor. 2 times 2 is 4. Okay, so now you're good. Now you can create your 2 cases. Case 1, negative 6 plus 2, radical 21 divided by 4. And then second case, negative 6 minus 2, radical 21 divided by 4. There are 2 cases here, plus and minus. Plus and minus. You cannot subtract negative 6 plus 2. You can't add those because there's a radical here. This is saying negative 6 plus 2 radical 21. You cannot add those. But you can divide. There's a divisor that both of these terms share, which is 4. So let's divide negative 6 divided by 4. So negative 6 divided by 4. We can also take the 2 radical 21 and divide it by 4. They share the same divisor, so you can do that. 6 out of 4, you can divide both by a 3, right? Or by a 2, excuse me. 6 divided by 2 will be 3. 6 divided by 4, 4 divided by 2 is 2. 6 divided by 2 is 3. 4 divided by 2 is 2. 6 out of 4 can be reduced to 3 out of 2. Keep your minus sign. Let's do 2 divided by 4. 2 out of 4 is the same thing as 1 out of 2. So, I think that works. You might be able to add these together and keep your denominator. Let's try that. Negative 3 plus 1 radical 21 over 2. That works because 3 out of 2 is 6 out of 4, and 1 out of 2 is 2 out of 4. So make sure it matches. I would write it like this. I would drop that 1. It's not necessary. There's your first x-intercept. Negative 3 plus radical 21 over 2. Okay, that's your first solution over here. Second solution, same thing. Just drop this down. It's the same numbers, right? So let's do the same thing. Negative 3 halves. This is a minus. This is a positive. So it'll be minus. And that's your answer. Okay? You have two solutions, and they're both radical. They're both going to be a decimal. And that's your second example. Make sure you get your steps in here, right? So your first step was to write in standard form. Write in standard form. Make sure it's in standard form. ID your ABC. ID your ABC, right? Write your formula. Write your formula. Plug in your numbers, right? Plug in your numbers. Or plug your ABC, whatever, right? Plug your ABC. Then you square it up, right? 6 squared. Then you square it up. Then you multiply. Then you add them up, right? Then you add them up. Then you square root, oh my, right? Square root, take the square root. Then you square root, oh my. Then you square root, oh my. Once you do that, 2, then you, what is that? Maybe then you need 2 solutions. Then you square, then you square root, oh my, wait. You need 2 solutions. Well, it might not be 2 solutions, right? Make 2 solutions, right? Make 2 solutions. Make 2 solutions. Then you divide, right? We might have to divide. Then you divide. Then you simplify. Then you simplify. Those are my x-intercepts. X-intercepts. Then you got your x-intercepts. So write your steps down. Go ahead and pause the video so we can go over it. And then you can pause it and write the steps down. So write in standard form. ID ABC, right? Write in standard form. ID ABC. Write your formula. Plug your ABC, right? B, A, C, A. Plug your ABC. Then you square it, plug your ABC. Then you square it up, right? Square it up. Then you multiply, Then you add them up. Then you square root, oh my, right? Factor tree. Make two solutions. Then you divide. Then you simplify. Then you got your x-intercepts, right? So you can have fun with it. So that's example 2. Write the steps down. We'll do one more example with an imaginary solution. Okay. All right. Say you have 3x squared minus 3x plus 9, right? So this isn't standard form, it's perfectly fine. So our A value is 3, our B value is -3, and our C value is 9. X equals negative B, right? Negative B is -3, plus or minus the square root of B squared minus 4AC all over 2A, which is 3. X equals +3, because our negative is a positive, plus or minus 9. -3 times -3 is 9. 4 times 3 times 9. There's one negative here, so it'll be negative. 4 times 3 is 12. 12 times 9. Is that 72? No, 108. 2 times 9 is 18. 108, yeah. 108, right? Double check your work. And then you subtract 9 minus 108. So you could take 108 minus 9, right? So that'll be 99. The bigger number is negative, so -99. This is called a discriminant, this here. If your discriminant is negative, then you're gonna have an imaginary solution. So make sure you know that. This is called your discriminant. Whatever is inside of here is called the discriminant. Discriminant. So if it's a negative, any number, it's going to be imaginary. Okay? All right. And then plus or minus 3 all over 6. 2 times 3 is 6. All right. So 99. We need to take this. You cannot take the square root of a negative number. You cannot take the square root of a negative number. It's impossible. So instead, go ahead and take the imaginary out of it. So rewrite square root -99 as -1 times 99. It's the same, these are the same things, right? So just like, for example, -8 is the same thing as -8 times 1, or -1 times 8. It's the same thing, just written differently. Right, so you're rewriting your negative radical, because we can't deal with a negative radical. Let's take the imaginary out. I, we call square root -1 I. If you don't know that, watch my imaginary video. And then do your tree, like normal, on the positive 99, which is 11 times 9, right? Then 3 times 3. There's a double, non-double. So your twin comes out as one number. Then you put your I. Then you keep non-twin in. The square root of -99 is 3i radical 11. So let's go ahead and rewrite this. Your x-intercept is 3 plus or minus 3i radical 11 over 6. Make two solutions, 3 plus 3i radical 11 and 3 minus 3i radical 11. then you divide, right? That's the steps. Look at your steps there. 3 divided by 6 is 1/2. 3 divided by 6 is also 1/2. That might be the way you see it, possibly, your answer choice. Same thing here. 3 divided by 6 is 1/2. 3 divided by 6 is minus 1/2 I radical 11. Both of these terms do share the same denominator, so I believe you can write it as, you can add the numerators, right? Keep the denominator. That's how you do math. If it's the same denominator, you can just add the numerators and keep the denominator. So 1 plus 1, keep your I radical 11, it doesn't disappear, and keep the same denominator. You don't need this 1. 1 plus 1I, it's just 1 plus an I, right? You could just do this. That's your first x-intercept. Same denominator, so subtract 1 minus 1 is 0. That's strange. I wonder if the answer is 0 then. This is what I'm saying about AI. I keep saying don't use it unless you're using it as a tool, right? Let's actually ask it a question, okay? Okay, the reason why I decided to not edit this YouTube video, right, because I can edit this all day long, make myself look super smart. I'm not interested in that. I don't care about that. I'm showing you real life, okay? So say you get stumped on a problem, use your sources. I'm not saying you can't learn from tools, right? I'm saying don't use ChatGPT to do all your freaking work. That's what I'm saying. Did Chat do this for me? No, I did this. You do this. I was just stumped on this part, and I was actually correct, and I see exactly what happened here. This is perfect. Everything I have is, I could do 1/2 plus I radical 11 over 2. Same thing. That is correct. Everything I have here is correct. Everything I have here is correct as well. I realized my mistake, right? 1/2. So this is saying 1 minus I over 11 over 2. Because you cannot subtract 1 minus 1. It's not 1 minus 1, it's 1 minus 1I radical 11, right? So it's 1 minus an I radical 11. That cannot be subtracted. So you just keep it how you see it and divide by 2. Or 1/2, and then just like here, minus this I radical 11 over 2. It's the same thing. Don't ask me why I got stumped. I feel silly. I get it. But sometimes your brain freezes and you're like, what? Right? For some weird reason, I said 1 minus 1 is 0. No. Technically, it's 1 minus 1I radical 11. So use this teaching point as a learning point for you, right? That use your sources to help you, even to check your work. It's fine, but do your own work, be authentic, and you'll get the right answers. So I feel so smart because I got it right, got it right, got it right, got it right. Give your own self a smiley face whenever you get it right. Get it, get it, get it, get it, get it tight, right? So that's how you solve quadratic equations with the formula. Those are your x-intercepts, your roots. Make sure you write down rocks somewhere. That way you know that means roots, zeros. If your test asks you for x-intercepts, solutions are all the same thing. Factors, that's why we started saying F rocks, F rocks. It's kind of inappropriate, but F rocks, right? Or frocks, like crocs, frogs. Write that down so you know these are all the same thing. It's where your parabola crosses the x-axis, or in this case, where it might not cross the x-axis, and now we're looking into the imaginary space where it crosses it in a different way. But yeah. So know your song, and you should be very successful as long as you do your steps. Know your steps.